Let's start, respecting everyone's time who have already joined here. Very good afternoon to everyone. Welcome to the webinar series sponsored by GRIDsentry on Powergrid cybersecurity topics. I sincerely thank everyone here for finding time to attend this talk. I'm Devika, CEO CTO of GRIDsentry. And a brief intro about GRIDsentry. We started off in September 2021 with my lab mates Samulya and Himanshu from IIT Madras under the guidance of Professor Shanti Swarup. Mr. Rajesh Reddy is my co-founder and is actively driving the business of GRIDsentry. Our R&D team is led by Dr. Tanushree and Prashant, who are rigorously working on different aspects of cybersecurity so that we can have a secure power grid. We are currently incubated at Indian Institute of Science, Bangalore, and our R&D works happen in the PGCOE lab that is out there in Indian Institute of Science. So today's talk is much more on a very fundamental topic of cybersecurity, focusing on substations. And it starts off by asking very fundamental questions like, why does a substation need cybersecurity? Why is substation a cyber physical system? And okay, if substation is a cyber physical system, how do I secure it? What is the first and foremost step that one should take to secure a substation? So the answer to it is basically answering the question, what is in your substation network? So that is today's topic. To basically set out a context, just a brief background, like that's how our grid is, right? We have major three components: generation, the transmission, distribution, and the end users. And all these distinct components are interconnected to form a grid by a very critical component that is called substations. With the advent of advanced communication technology, more digitalized solutions that we have, these substations have grown into a digital substation. So a typical digital substation would be something like this, like you have a physical layer wherein there is your current transformers, potential transformers, circuit breakers, your transformers, which actually does the step up and step down of voltage. That is your physical layer. All these current measurements, voltage measurements are analog values. They are fed to a merging unit, which merging unit converts it to a digital values, which are fed to IEDs. IEDs are the protection and control logic deciders within the substation. So it continuously monitors the network to look for any high current, high voltage, low voltage situations. Any fault scenarios are analyzed by IEDs, and trip signals are sent accordingly by IEDs to secure the grid. So these signals are happening by basically merging units would send out sample values to IEDs. IEDs would then communicate across each IEDs to come up to a protection control logic, that is through goose messages. And IEDs would send back goose messages to the circuit breakers so that the trip commands or the restoring of the system happens within the network. IEDs can be remotely controlled, that is using a SCADA system, a HMI system, which is out there either locally within the substation, or it can be at a remote control center as well. And those messages again happen using goose and MMS. Thus, you can see that a substation is controlled or driven totally by a cyber system where you have intelligent devices speaking across each other in a well-knit communication network. And basically because of this, what happens is we are prone to cyber attacks. There might be installed malwares existing already in these devices out there. Even attackers can intrude into the network with by hacking the systems, etc. Above all, what is most important and scary over here is that these goose messages and sample value messages are not encrypted. So if there is an attacker presence within the network, the attackers can easily manipulate these messages and cause severe destruction. In the sense, like if there is an actual high current scenario and the attacker tries to mask it, your IEDs are not going to ever know about such a scenario. which will result in a high current to flow throughout the network, which might even blast your transformer and even cause loss of life. So that is where the depth of this problem lies. And the severity is the securing of substations is so much important, and that is where we are looking into. So what are the major things that we have to consider in securing digital substations? So there are 4 pillars that we can think of. The first pillar that is out there is confidentiality. It's not everyone who should be able to access these IEDs. There should be a well-defined authorization that could be given so that the confidentiality of the messages flowing out there, etc., are maintained. But this should not hamper or cause any hurdles to the availability of the network, because more than cybersecurity, what is more important is the protection and control logic of the substation. So that should not impair the availability of the substation devices while you restrict so much in the confidentiality. Also, there should be some accountability. So this role is assigned to these particular people within the organization. And above all, what you need basically through these activities is the integrity of messages that are flowing in the network. You just don't need any hacked messages flowing. You need authority in every messages. So all these aspects are to be well knit when you are considering any cybersecurity solution for a substation. Confidentiality, availability, accountability, and integrity. So these are the ultimate goals that we have, and also at the same time, the pathway to secure substations. So where do we start? First step is to know what is in your network. So you have to identify the different cyber assets that are sitting there in the network, be it IED, be it the merging units, your switch, routers. There are multiple things that are sitting there. You have your GPS clock, lots of things would be there, your PLCs, you have RTUs. So you may not exactly know what is sitting there in your network, the substation communication network. So identifying what is there in your network is the primary step that you can take. Not just that, you just don't want to know who are there. You have to know, in addition to, what do they speak and to whom are they speaking to. So basically, the network topology and the cyber assets is what we'll have to first identify when we are doing any cybersecurity solution for a substation. So we understand that we have to identify your network, you have to identify your cyber assets. But is that something hypothetical? Not really. Why? Because there is this standard called NERC-CIP, which has come from the US, the North Electrical Region, and it's on critical infrastructure. They have this mandate saying that evaluation of security patches within these cyber assets that we have should be done almost every 35 calendar days. Also, there should be a vulnerability assessment of these devices that are there in the network every 15 calendar months. So that is a mandate that is coming from the regulation as well, and it is not just something hypothetical. That is just maybe NOXIP is in the US, and though it's accepted worldwide, India is not far. We are having our own methodology also. There's this new draft that has come up from CEA, which mandates such patch management and vulnerability assessment half yearly. And in fact, India has made a much more better step. We have our own standard on this called IS 16335, which considers all these aspects as I've been discussing: confidentiality, accountability, the availability, and integrity. So all these concepts, how do we achieve it through a substation cybersecurity solution, is well discussed in this standard. So everywhere, the fundamental policy is to understand what is there in your network. So what do we know? What do we identify? Okay, we might know, okay, I have an ABB relay, I have a Siemens relay, etc. But what exactly should I know if I want to assess my cybersecurity posture within a substation? So the key elements over there are to understand the make of the asset, to understand the model of the asset, hardware version, firmware version. So these 4 components are so very critical to analyze or to have an information repo always, because it is at this level that any OEMs would declare their vulnerabilities and exposures. So it is at these detail levels that the cybersecurity R&D happens. So from a substation operator perspective, knowing these information of every asset in the network is very important so that any cybersecurity hardening techniques or strengthening techniques that are to be implemented within the substation would go by upon these rules. And it is not just something that you have to close it over there. This is quite of a periodic identification that is required because the firmware might get updated. You will have to update your firmware because there has been a CV, there has been a vulnerability or an exposure that has already been identified against that asset. Thus, these things are quite dynamic these days when compared to earlier, because earlier so much of an R&D against cybersecurity was not happening. And the firmware once it gets upgraded only once you face any difficulty within the communication network, not compatible with your SCADA system, etc. But that is not the case now. You have continuous R&D happening against these OEM networks, and these OEMs are specifying the vulnerabilities and exposures against these combo, and thus periodic identification of this combination of make, model, hardware version, firmware version of the cyber assets that are driving the substation protection control logic is so very important. So this is what we have to identify. And nowadays, this is being done so much of a manual process. It's quite a gender bias picture over here. But still, you have a system operator or an engineer who goes out to the field, to the yard, go to each kiosk within the yard, understand each model, what is there, what is each device sitting there first, then begin upon the make, model, firmware, hardware version, which is much more a very tedious process that is going to happen. And it eats up most of the time of an operator because it's not just cybersecurity that the operator has to take care of. It has to take care of the daily preventive maintenance activities and quite a difficult task that is out there. In addition to that, if the operator has to go out to the yard and get all these details, it's going to be really tough. But at the same time, it's quite very important because once you have an attack into the system, and open your ways out to the attacker, you just don't know where the attacker has got into. So maintain the cybersecurity posture is so very important, and manual process is not something that is quite a feasible thing as the attacker becomes more smarter. And it's much more of a state sponsored activities these days to attack cybersecurity, attack the substations. So quite a sorry state over there. So manual process is not something that is going to work. So we will have to automate all these processes. So basically GRIDsentry has a solution for it, which is called GDiscover, wherein we automatically identify the assets that are there in the network and get the detailed asset inventory list. So basically, users have to plug in GDiscover into the substation network. It will fetch the complete details of the network, like identifying the assets, identifying the network topology, thereby getting a detailed asset inventory list. So by the detailed asset inventory list, as I said, it is that combination that is most required. It works on 61850 protocol, etc. And as I said, like we have to have that particular combination information to maintain or to harden your cybersecurity posture within the substation. So the part number, model number, as you see up here, this is what you get from GDiscover. It's a part number, model, hardware version, firmware version, etc. Is what you get for each device that you have there. Like you have multiple, and it's not any OEM specific, it's OEM agnostic. You get irrespective of the vendor. The only thing is it's based upon the protocol, especially for a digital substation, it is much more on the 61850 side. In addition to getting the asset inventory list, we also give the network topology, like as I said, which asset talks to which, how is the network architecture happening is also very important because that information helps to identify where is the attacker, which part of the network is more vulnerable to attack and things like that. So that is quite important, even in case of unfortunate events of any cyber attack, to track the path of the attacker, also the network topology is so very important. So that is also given out by GDiscover. And irrespective of what is there existing in SCADA, you will need much more of a live network topology. It's much more of a dynamic network topology that you need. So if there is a new device entering into the network, that also should be given out. So that is what basically GDiscover is doing. You get a network architecture and give out alarms as and when there is a new device entering into the network, and also at the same time when there's a device that has been deleted from the network or taken away from the network, also you get alarms. So basically this is a alarm that you get for physical intrusion, in the sense not physical of a physical device intrusion, I should specifically say, and give out alarms. So this is the first and foremost step that you can take for a substation to be making it more cyber secure. Yeah, so this is what we have. Ultimately, what we wanted to say out over here is this is more of an R&D work happening. You have a very challenging problem. Not many people are working on this, and even the industry, we do not have a proper solution over here. There is an urgent market demand, and at the same time, we need good industry academia connect to develop state-of-the-art technologies. So basically, this is what I have today to discuss, and I'm open to questions, please. Thank you for listening. Any questions?
Devika, there's one question on the chat.
Oh, okay, I'll take it up. Is cybersecurity for a substation different from that of a bank IT system, for example? If so, how? And what are the unique security challenges for a substation? Yeah, for a bank IT system, you are dealing much more of computers over there. Your time criticality is quite less. But when you are dealing with substations, you are dealing with very time critical messages out there. If you go by the standards, your sending and transmission, like the whole protection control logic should happen within 4 milliseconds. So your response towards any cyber attack is also at that level when compared to any other banking IT systems to some extent. Your time is much more of a factor here. Apart from that, the device, the supply chain, etc., which is existing in the substation network is quite very unique. You have multiple vendors sitting there, multiple, like as I said, the make, model, firmware, hardware, these kind of complexities do not come up in a bank IT system. That makes substation cybersecurity quite very unique. I hope I've answered you. Yeah, maybe I can unmute. Yeah, hello. Hi, Chandramouli. Are you
Hi,
able
can you hear me?
to? Yeah. Yes, I can hear you. Yes, very well.
Yeah, my quick question is, how do you ensure that GDiscover is not hacked?
Good question. GDiscover by itself is a software, and as any other company should be taking care and things like that, it's as per the secure software development life cycle. The deployment is such that, and all 62443 certification and things like that are on the way.
No, but that's all fine. But GDiscover also will sit in one of the layers of your digital station, right?
Right, right.
So I'm a hacker. I can hack into GDiscover.
True. That is like any other device in the network. I don't deny it. So the cybersecurity posture and strengthening applies to GDiscover also at the same time. So it just not that we have to deploy it over there in the network and go off. Periodic update, periodic R&D on the network is part of it.
Okay.
Yeah, okay, there's one in the Q&A. What is the device deployed to monitor the Goose protocol? It is GDiscover itself that is there. Via GDiscover, we are monitoring the Goose protocol. Not really sure with the question, but maybe if you can unmute and speak. Yeah, Bipin, I hope you are able to unmute yourself. No, I can't hear. Yeah, okay, there's one more question in the chat. How GDiscover able to judge the topology? What inputs is required to judge the topology? It's mostly the message packets that are flowing in the network are passively observed to identify the network topology. So message packets is a key thing over there, where the packets are analyzed to understand the architecture of the network and then bring up the hierarchy. Yeah. Bipin, are you able? Hi, Bipin. I hope you are able to hear me. Are you able to unmute yourself? We have enabled your mic. Do we have any more questions? Yeah, okay, Prashant.
Yeah. Yeah, thanks, Devika. Yeah, hello and very good afternoon to everyone. I'm Prashant Marnat. I'm the Product Development Manager at GRIDsentry. So on behalf of GRIDsentry, I would like to thank all of you for your participation in this webinar. And we look forward to collaborating with you, towards improving the OT cybersecurity in electric grid networks. And also a very special thanks to Professor Shanti Swarup for your participation. Sir, we would like to know your thoughts on the topic of today. Would it be possible for you to share a few thoughts?
It's a very good presentation and it's eye opener for me as well. So some of our students have also joined this. So we're very proud of Devika and her work. Okay.
Sure.
Thank you.
Thank you. Thank you. Okay, thanks everybody. If you have any other questions, we're always, please do send us an email. We can always get back to you over email as well. Thank you, everybody.
Thank you. Thank you.